Right now, while your motorcycle feels perfectly normal, there may be a single dirty sensor quietly stealing horsepower, increasing fuel consumption, and shortening your engine's life without triggering a single warning light on the dashboard. Reputable motorcycle shops see this exact pattern every single day. The bike comes in underpowered and thirsty. Spark plugs get replaced. Injectors get blamed. Nothing changes. The problem only disappears when a sensor nobody touches finally gets cleaned. The mass airflow sensor is one of the most critical and most ignored components in any modern fuel-injected motorcycle. Its job is to measure with extreme precision every gram of air entering the engine. To do this, it uses an ultra-thin platinum wire, almost as fine as a human hair, electrically heated to a constant temperature. As air flows past it, the wire cools in direct proportion to the speed and volume of incoming air. The engine control unit measures the electrical current needed to maintain that temperature and converts it instantly into air mass data. The disaster begins when microscopic dust particles, oil vapor from the crankcase ventilation system, or residue from oiled performance air filters settle on that delicate wire. Its thermal behavior changes completely, and the engine control unit starts receiving inaccurate airflow data. The result is a confusing mix of symptoms. There is noticeable power loss during harder acceleration. You get unexplained increases in fuel consumption. Idle becomes unstable, coming and going. And in more severe cases, the engine stalls during sudden deceleration when you snap the throttle closed coming into a corner. In professional diagnostics, roughly 40% of motorcycles showing rich or lean mixture fault codes do not have a failed mass airflow sensor. They have a contaminated one. Proper cleaning requires a dedicated mass airflow cleaner spray and absolutely no physical contact with the sensing element. Touch that wire and the sensor is destroyed. But the mass airflow sensor only tells the engine control unit how much air is coming in. There is a second sensor measuring something different entirely, and when it fails, the symptoms look almost identical. The Manifold absolute pressure sensor is used on motorcycles that run a speed density fueling system rather than a mass airflow sensor. Instead of measuring air directly, it measures the vacuum pressure inside the intake manifold using a piezoresistive element that changes electrical resistance as pressure changes. At idle, with the throttle closed, intake vacuum is high and pressure readings are low. Under wide-open throttle, vacuum nearly disappears and pressure rises toward atmospheric. The engine control unit combines this data with intake air temperature and engine speed to calculate incoming air mass. Problems start when the vacuum hoses connecting the sensor to the intake manifold become brittle, cracked, or partially disconnected from vibration. Even a tiny vacuum leak completely distorts the readings. The sensor reports higher engine load than reality, the engine control unit injects excess fuel, and the engine runs rich. The symptoms are heavy fuel consumption, black smoke from the exhaust on startup, and persistent rich mixture codes that send riders chasing injector problems that do not exist. In motorcycle workshops, simply cleaning the manifold absolute pressure port and inspecting the vacuum line solves roughly 80% of issues that were blamed on the sensor itself. The hose costs $2. The vacuum leak it causes costs you a season of poor running and a diagnostic fee. Move further down the intake tract, and there is another sensor doing a completely different job, one that almost nobody on a motorcycle ever thinks about until it fails emissions testing. The oxygen sensor is the engine control unit's eyes inside the exhaust system. It constantly monitors combustion efficiency and adjusts the air-fuel ratio thousands of times per minute. It uses a zirconia ceramic element, heated above 300 degrees, that generates a voltage based on the oxygen difference between the exhaust gases and outside air. At the ideal stoichiometric ratio of 14.7 parts air to 1 part fuel, the sensor outputs roughly 0.45 volts. Lean mixtures drop the signal below 0.3 volts. Rich mixtures push it above 0.6 volts. The engine control unit uses these rapid fluctuations to fine-tune fuel delivery in real time on every single combustion event. The real damage happens when the sensor becomes contaminated by residues from poor quality fuel or oil burning from worn piston rings. These contaminants chemically poison the sensing element, slow its response, and reduce its accuracy. The result is sluggish mixture correction, higher fuel consumption, noticeable power loss through the mid-range, and almost guaranteed failure during emissions testing. Many riders have fitted expensive aftermarket exhaust systems trying to fix a flat mid-range that was caused entirely by a contaminated oxygen sensor that a $15 cleaning would have resolved. Now move away from air and fuel measurement entirely. There is a sensor that controls something more direct, exactly how much throttle you are actually asking for. The throttle position sensor is a high-precision potentiometer mounted directly to the throttle shaft. It tells the engine control unit exactly how much acceleration you are requesting at any given moment. Inside, there is a resistive track and a moving wiper that divides reference voltage according to throttle angle, ranging from approximately 0.5 volts at idle to 4.5 volts at full throttle. With this signal, the engine control unit decides whether you want fuel economy or maximum performance, adjusting fuel delivery and ignition timing accordingly. Problems arise when the internal track wears out or becomes contaminated, creating dead spots at the most commonly used throttle positions. On a motorcycle, those dead spots tend to appear at the partial throttle positions used for steady highway cruising and gentle urban riding. The rider feels hesitation coming out of slow corners, jerking at steady throttle, and momentary power loss at specific throttle positions that makes the bike feel like it is misfiring. Technicians diagnose this by monitoring voltage output on a scan tool while slowly opening the throttle, looking for sudden jumps or drops in the signal rather than a smooth, progressive curve. But if the throttle position sensor tells the engine control unit what you are asking for, the next sensor tells it something even more fundamental. It tells the engine control unit where the engine actually is in its rotation. Without a crankshaft position sensor, a modern motorcycle engine is effectively blind. Mounted near the crankshaft or a toothed reluctor wheel, this sensor generates precisely timed electrical pulses as teeth pass its magnetic tip. The engine control unit relies on this signal to know the exact position of each piston and the engine's rotational speed, determining the precise timing for fuel injection and ignition on every single revolution. When this sensor accumulates metal shavings, burnt oil residue, or general grime from years of engine bay contamination, the signal becomes distorted. The result is intermittent misfires, sudden hot engine stalling, long crank times on a warm engine, or brief ignition loss at specific revolutions per minute ranges that feel exactly like a fuel delivery problem. In many workshops, simply cleaning the sensor tip with a lint-free cloth and electrical contact cleaner restores full stability to engines that seem to be suffering from serious ignition or fuel system failures. Riders have spent hundreds of dollars on new coils and injectors, chasing a problem that was sitting on the end of a sensor that needed 5 minutes and a cloth. The engine control unit needs to know engine temperature to get fueling right, from cold start to operating temperature. There is one sensor responsible for all of it, and it is one of the most prone to contamination on any motorcycle. The engine coolant temperature sensor is the engine control unit's internal thermometer. It tells the engine management system whether the engine is stone cold, warming up, or at operating temperature. Based on this single data point, the engine control unit enriches the mixture during cold starts, holds idle speed higher while the engine warms, commands the radiator fan at the right moment, and adjusts ignition timing for thermal conditions. When this sensor becomes contaminated or develops oxidation at the terminals, the engine control unit may believe the engine is permanently cold. Fuel consumption spikes because cold start enrichment runs continuously. The radiator fan may fail to activate at the correct temperature, pushing coolant temperatures into ranges that stress gaskets and seals. Hot restarts become difficult because the injected fuel quantity is calibrated for a cold engine. Always work with the engine completely cold. Locate the sensor, typically threaded into the cylinder head or thermostat housing. Release the connector and inspect the terminals. Green oxidation, white sulfate buildup, or oily residue on the pins is what you are looking for. Electrical contact, cleaner applied directly to the terminals, resolves the majority of issues without removing the sensor. A properly functioning coolant temperature sensor eliminates a long list of intermittent problems that feel mysterious but come down entirely to a dirty connector lying about engine temperature. And the last sensor on this list is the one almost nobody ever thinks to clean. The one that fails most often, causes the most confusion, and can completely transform how your motorcycle runs in under 10 minutes. This is the real most overlooked trick in motorcycle maintenance. You can have brand new sensors, premium oil, fresh spark plugs, and a clean air filter. If the electrical signal those sensors produce travels through oxidized, sulfated, or loose connectors, the engine will still misbehave. Every symptom that every sensor on this list produces can be replicated entirely by a single corroded connector in the wiring harness. Motorcycles are exposed to more vibration, more temperature cycling, and more moisture intrusion than almost any other vehicle. Connectors that are perfectly fine on a car deteriorate faster on a motorcycle. A single pin with green corrosion, moisture trapped inside a connector body, or a terminal that has worked loose from vibration can cause intermittent misfires, random fault codes, and warning lights that appear and disappear without logic. The process is straightforward, but demands attention. With the engine off and completely cold, work through the critical sensors one by one: mass airflow, manifold absolute pressure, throttle position, oxygen sensor, crankshaft position, and coolant temperature. Release each connector lock, disconnect without pulling on the wiring, and inspect inside. If you see oxidation, dirt, or oil, you have found a major source of problems. Apply electrical contact cleaner to both the male and female sides of the connector. Let contaminants drain out. If sulfate buildup is stubborn, use a small plastic bristle brush gently, never use metal, and never blast compressed air directly into the pins. Let everything dry completely. Apply a thin layer of dielectric grease around the connector seal to prevent future moisture intrusion. Reconnect until you hear the click that confirms solid contact. Running this connector check across every sensor on the engine fixes more problems than blindly replacing parts. Intermittent codes vanish, strange running behavior disappears, and your motorcycle stops acting like it has a mind of its own. Before you spend a single dollar on a new sensor, clean the connections the entire electronic system depends on. Clean every sensor connector before you replace a single part. Never let a dealer charge you for a new sensor when a 10-minute cleaning would have solved it for free. If this saved you money, subscribe, drop a like, and tell me in the comments which sensor turned out to be the cause of your running problems.